Welcome to ZoomInData. Hello everyone. Thank you for joining this focused session on durable functions patterns in Azure Functions. We will cover all the classic and advanced durable functions patterns: function chaining, fan-out, fan-in, human interaction, monitor, async HTTP, saga, entity functions, aggregation, eternal orchestrations, and best practices for choosing and implementing them. If you are preparing for certification, an interview, or building reliable, long-running workflows, this session will give you clear, ready-to-use knowledge. If you find it helpful, please like, share, and subscribe to ZoomInData for more Azure deep dives. Let us begin. What are common durable functions patterns? Function chaining is the simplest pattern. It executes activities one after another in a fixed sequence. Fan-out, fan-in runs many parallel tasks and then aggregates the results into a single final step. Human interaction waits for external input, such as manual approvals or user decisions. Monitor pattern periodically checks a condition until it is satisfied or a timeout occurs. Async HTTP API pattern returns immediately to the caller and provides a status endpoint for polling. Other common patterns include aggregator, saga, eternal orchestrations, and stateful entity functions. Explain function chaining pattern. Function chaining executes activities one after another in a fixed sequence. The orchestrator function calls each activity function sequentially using call activity async. Each step must complete before the next one begins. It is simple, reliable, and easy to debug, ideal for linear workflows like process payment. Update inventory. Send confirmation email. How does fan-out, fan-in work? Fan-out starts many parallel activity functions at once using a loop and task, when all. Each activity runs independently. For example, process 100 order items in parallel. Fan-in waits for all parallel tasks to complete and then aggregates the results. This pattern reduces total execution time dramatically for parallelizable work. Describe the human interaction pattern. The human interaction pattern pauses the orchestration and waits for external input from a person. The orchestrator raises an event or creates a timer and waits using wait for external event. A person approves via a web UI, mobile app, or email link. This triggers the event. Use timeouts to escalate or cancel if no response arrives after a set period. What is the monitor pattern? The monitor pattern periodically checks a condition until it is satisfied or a timeout occurs. The orchestrator creates a timer and loops with create timer and call activity async. Example: check stock price every 5 minutes until it drops below a threshold. It is ideal for polling scenarios without constant resource consumption. Explain the async HTTP API pattern. The async HTTP API pattern returns HTTP 202 accepted immediately for long-running operations. The orchestrator starts the workflow and returns a status URL to the client. The client polls the status endpoint until the operation completes or fails. Use it for HTTP-triggered functions that take more than a few seconds to finish. How do you implement aggregation with fan-out? Start fan-out by creating a list of tasks with call activity async inside a loop. Use task when all to wait for all parallel activities to finish. Aggregate the results in the orchestrator. For example, sum totals or combine reports. Persist partial results in case of failure and restart from checkpoint. What is the stateful entity pattern? The stateful entity pattern models persistent stateful objects with unique identity. Each entity has a unique ID and can be called concurrently with automatic locking. Use it for per instance state, like per user shopping cart or per device status. Entities support operations like add, update, delete, and signal events. Explain critical section for concurrency control. Critical section ensures only one operation runs at a time on an entity. Durable functions automatically locks the entity during entity function execution. Use it to prevent race conditions, for example, incrementing a counter safely. Concurrency is serialized per entity ID. Other calls wait or fail if locked. How do you handle long-running approvals? Use the human interaction pattern with wait for external event. Create a timer for timeout, for example, 7 days for approval. If approved, continue orchestration. If timeout, escalate or cancel. Send approval link via email or Teams. Client calls back to raise the event. What is the eternal orchestration pattern? Eternal orchestration runs forever or until explicitly stopped. The orchestrator calls itself recursively with continuous new. Use it for always-on monitors or infinite loops with state preservation. Be careful, it never completes, so use timers or external stop signals. Explain sub-orchestrations for modularity. Sub-orchestrations allow you to call one orchestrator from another. The parent orchestrator uses call sub-orchestrator async to invoke a child. Child orchestrator runs as a separate workflow but is tracked in the parent. Use it for reusable modules, for example, payment processing or approval subflow. How do you implement retry with exponential backoff? Use built-in retry policy on call activity async, specify max attempts and backoff. Example, await context, call activity with retry async, process, retry options. Custom retry logic can be written inside the orchestrator with timers. Best practice, exponential backoff for transient failures like network issues. What is the aggregator pattern? The aggregator pattern collects events over time and computes a running state. Use entity functions to maintain the aggregated state, for example, total sales per customer. External events update the entity. Queries return current value. Ideal for real-time summaries, counters, or leaderboards. Explain event sourcing with entities. Event sourcing stores all state changes as a sequence of events. Entity functions apply events to rebuild current state on demand. Use it for auditability and replay, for example, order status history. Combine with durable functions entities for persistent event stream. How do you handle timeouts in patterns? Use create timer in orchestrator to set deadlines. If timeout expires, cancel, escalate, or take compensating action. For human interaction, pair timeout with wait for external event. Use continue as new to restart long-running orchestrations with timeout reset. What is the saga pattern in durable functions? The saga pattern coordinates distributed transactions without two-phase commit. Each step has a compensating action. For example, book hotel right pointing arrow cancel hotel on failure. Orchestrator calls activities and tracks state. On failure, runs compensations in reverse. Use it for reliable cross-service workflows like order processing. Explain reliable messaging with patterns. Use durable functions to guarantee at least once delivery with retries. Fan out, fan in ensures all messages are processed before completion. Idempotency in activities prevents duplicate side effects. Combine with service bus or event grid for durable queues. How do you version patterns? Use orchestrator versioning with continue as new and version parameter. Store version in orchestration state. Route to old or new logic. Deploy new orchestrator functions without breaking old instances. Use sub-orchestrations to isolate versioned modules. What is the role of external events in patterns? External events allow external systems or humans to signal orchestrations. Orchestrator waits with wait for external event for a named event. Used in human interaction, saga compensation, or asynchronous callbacks. Events can carry data, for example, approval status or updated values. Explain parallel approval workflows. Use fan-out to create multiple parallel tasks for approvals. Orchestrator waits with task when all for all approvals. Add timeouts per approval. Escalate individually if needed. Aggregate results. Require all approvals or majority. How do you monitor pattern executions? Use application insights for end-to-end tracing of orchestrators and activities. Query custom events. Orchestrator started. Activity completed. Orchestrator failed. Set alerts on failure rates or long-running orchestrations. Use durable functions monitor tool or custom dashboard in Power BI. What is the difference between orchestrator and entity? Orchestrator functions define workflows, they call activities, wait for events, and manage sequence. Entity functions manage stateful objects, they handle operations on a single entity ID with concurrency control. Orchestrators are ephemeral, entities are persistent and addressable. Use orchestrators for processes, entities for state-like carts or counters. How do you test durable patterns? Use the Durable Functions Test SDK for unit testing orchestrators and activities. Mock activity calls and external events in test code. Test timeouts, retries, and compensation logic with simulated failures. Run integration tests against a local storage emulator or Azure Storage. Best practices for choosing and implementing patterns. Choose function chaining for simple linear flows. Use fan-out, fan-in for parallelizable work. Ensure idempotency. Apply human interaction for manual steps with timeouts and escalation. Use monitor for polling scenarios. Avoid infinite loops. Implement Saga for distributed transactions with compensation. Make all activities idempotent and traceable. Monitor executions and set alerts on failures or long runs. Thank you for watching this complete guide to durable functions patterns in Azure Functions. From function chaining to Saga, human interaction, and best practices. If this session helped you with certifications, interviews, or building reliable workflows, please like, share, and subscribe to ZoomInData. More Azure deep dives are coming soon. Stay connected and keep learning. Thank you. See you in the next video.